Assalamu alaikum. Our research is about relay and it's done by Mina, Dina, Mauj and Mustafa. Relay. What is a relay and how it works? Relays are the primary protection as well as switching devices in most of control process or equipment regardless of whether they are electronic or electromechanical. All the relays respond to one or more electrical quantities, like voltage or current, such that they open or close the contacts of circuits. A relay is a switching device as it works to isolate or change the state of an electric circuit from one state to another. These are found in all sorts of devices. Relays allow one circuit to switch over to a second circuit that can be completely separated from the first. There is no electrical connection inside the relay between the two circuits. The link is magnetic and mechanical only. This is electromagnetic relay. How the relay works? Basically, a relay consists of an electromagnet coil, an armature, a spring, and a series of electrical contacts. The electromagnet coil gets power through a switch or a relay driver and causes the armature to get connected such that the load gets the power supply. The armature movement is caused using a spring, thus the relay consists of two separate electric circuits that are connected to each other only through magnetic connection, and the relay is controlled by controlling the switching of the electromagnet. The contacts are usually common, normally open and normally closed. The normally open contact is connected to the common contact if power is not applied to the coil. The normally open contact is opened if the power is not applied to the coil. When the coil is energized, the common contact is connected to the normally open contact and the normally closed contact is left floating. The double pole version are same as the single pole version, except when the two switches open and close together. What is the applications of relays? Number 1. Control a high voltage circuit with a low voltage signal as in some types of modems or audio amplifiers. 2. Control a high current circuit with a low current signal as in the starter solenoid of an automobile. 3. Detect and isolate faults on transmission and distribution lines by opening and closing the circuit breakers. 4. Time delay function. Relays can be modified to delay opening or delay closing set on contacts. A very short delay uses copper disc between the armature and moving blade assembly. Typically, applications of relays include computer interfaces, telecommunication systems, traffic control, automotive, electrical systems, and so on. What is the classifications of relays? Classifications are the types of relays depends on the function for which they are used. Some of the categories include protective, reclosing, regulating, auxiliary, and monitoring relays. Protective relays continuously monitor these parameters, voltage, current, and power. And if these parameters violate from the set limits, the protective relays generate an alarm or isolate that particular circuit. These types of relays are used to protect equipment like motors, generators, and transformers, and so on. Some of these are induction type over current relays, distant relays, differential relays, etc. Reclosing relays are used to connect various components and devices within the system network, such as synchronizing process and to restore various devices soon after any electrical fault vanishes. and also to connect transformers and feeders to online network. Regulating relays are the switches that contact such that a voltage boost up, as in the case of tap changing transformers. Auxiliary contacts are used in circuit breakers and other protective equipment for contact multiplications. Monitoring relays monitor a system condition such as direction of power and accordingly generate an alarm. These alarm relays are also called as directional relays. Depending on the operating principle and structural features, relays are of different types: electromagnetic relays, thermal relays, power varied relays, multidimensional relays, and so on. With varied ratings, sizes, and applications, these relays are constructed from electrical, mechanical, and magnetic. Electromagnetic relays. These relays are constructed from electrical, mechanical, and magnetic components and possess operating coil and mechanical contacts. Therefore, when a coil gets activated by a power supply source, these mechanical contacts get open and closed. The type of supply can be AC or DC. Both AC and DC relays work on the same principle as that of electromagnetic induction, but the construction is somewhat differentiated and also depends on the applications for which these types are selected. DC relays are employed with a freewheeling diode to re-energize the coil, and the AC relays use laminated coil cores to prevent eddy current losses. The very interesting aspect of an AC is that for every half cycle the direction of the current supply changes. Therefore, for every cycle the coil loses its magnetism, since the zero current in every half cycle makes the relay continuously make and break the circuit. So to prevent this, additionally one shaded coil or other electronic circuit is placed in the AC relay to provide magnetism in the zero current position. The first type is attraction type electromagnetic relays. These relays can work with both AC and DC supply and attract a metal bar or a piece of metal when power is supplied to the coil. This can be plunger being drawn towards the solenoid or an armature being attracted towards the poles of an electromagnet. As shown in the figure, these relays don't have any time delays, so these are used for instantaneous operation. These can be typed like attracted armature relay, solenoid type relay, and balanced beam relay. Induction type relays. These are used as protective relay systems. The actuating force of contacts movement is developed by a moving conductor that may be a disc or a cup. Through the interaction of electromagnetic fluxes due to a fault current. These are of several types like shaded pole type relays, watt-hour meter type relays, induction cup structure relays. Shaded pole relay consists of an aluminum disc which is pivoted such that it freely rotates in the air gap of an electromagnet. Shaded ring or copper ring is surrounded on the half of each pole. The induced current in this shaded ring produces another flux called as shaded flux, which lags behind the flux produced by the unshaded pole by some angle. The phase difference between these two fluxes produces necessary torque to rotate the disc. Watt-hour structure type relay work as an electromagnetic induction type of watt-hour ammeter, so named after it. It consists of two magnets, upper and lower electromagnets, and aluminum disc which is pivoted such that it rotates freely between the two electromagnets. In this relay, the upper magnet consists of two windings, primary and secondary windings, wherein the primary winding carries the relay current and the secondary winding is connected to the lower magnet. This primary current induces EMF in the secondary winding, so it produces a flux that lags behind the main flux by some angle. The phase difference of these fluxes produces torque on the disk, whose magnitude is proportional to the product of these two fluxes multiplied by the sine angle between these two fluxes. The induction cap structure works on similar principle of an induction disk relay. This relay can be 4 poles or 8 poles depending on the number of windings accommodated. Due to the replacement of this disk with an aluminum cap, the interior of the rotating system is significantly reduced in this type of relay. The rotating magnetic field is reduced by one pair of poles inducing a current in the aluminum cap. In this relay, the cap movement or torque is produced by the interaction of field produced by the two pair of poles that have lagged one another with some angle. In the normal operating conditions, the cap remains standstill, but in case of any fault, a very high current in the coil causes to move the cap, so the circuit gets isolated from the power supply. Temperature control thermal relays. These relays are used in motor winding protection and use temperature sensors like thermistors and resistant temperature detectors. These sensors are embedded in the motor winding, which detects the temperature and their short circuit in its open relay contact. Furthermore, these thermal relays can be oil temperature trip, winding temperature trip, and bearing temperature trip types. Relays are also available with different pin configurations, like 3-pin, 4-pin, and 5-pin relays. The ways in which these relays are operated is shown in the figure below. Switching contacts can be SPST, SPDT, DBST, and DBDT types. Some of the relays are normally open type and the other are normally closed type. These are some basic types of relays commonly used in different applications concepts, like choosing relays based on capacity and mathematical calculations related to a relay operation are exempted in this document for making it simple to understand. Some of the relays, like distance relays, directional relays, and other power system protection-based relays, are not included in this document, in order to make this document short and precise. Thank you for listening. I hope it was useful.